Right, before encoding more instructions, I just want to improve my testing situation. So right now I have to write the assembly tests in here, and then I have to go over to the encoder test, and I have to copy those over to here and change the syntax and everything. What I'd like to do is, for example, with this bottom one here, I'd like to have a comment in the assembly file itself, where I basically just have a simplified form of this syntax. So for example, I could separate by spaces instead of with commas. I wouldn't need to call functions specifically. I can just annotate with these sort of attributes. And then I can basically parse this out on the Go side to generate the test for the current line. So that's what I'm going to work on this time before getting into more instructions. So to make sure this works properly with copying over the tests, I just need to get rid of these comments here. And then I'll just go and take all of these tests across. So we'll just go to the very top. Let's select everything. Get all of the non-empty lines and put a new comment here. So we'll just go to the first semicolon, and then in this selection here, we'll basically look for anything that is NA and replace it with nothing. And then we'll do the same thing again. So let's just take this semicolon. And then within the selection, we'll find all comma space and replace it with just a space. Okay, so let's just line all of these up. Let's get rid of this ending thing here. So we'll just go to all of the commas again, semicolons again. Get rid of that on the end. Okay, so there's going to be a few here that I need to change around a bit. So these ones, for example, I want to make sure that the test comment is the first thing that's seen. And then any sort of trailing comments I'll do as like a double slash sort of comment here. So we'll just take these ones off. And those will go on the end there. There's also things like lock comments. These sort of prefix ones. Let's just line those up as well. I think that might be about it. There could be some other comments. There's these comments about SAE or rounding being valid, but NASM not accepting it. So we'll just do those as well. Okay. All right, that should be about it. So now if I just clean up this syntax a bit, get rid of any empty parens, stuff like this K here, can just be the argument that gets passed in. Same goes for things like I for immediate. We'll just take the contents of the call here. That should also apply for D. And there's also D8. And D32. Let's find some other function calls. So ER here can just be the contents of the call. Same goes for this W1 here. SI isn't really needed because if I see something like X1, it means that, you know, it's going to be a scaled index anyway. So I'll just take the contents of this call, get rid of SI, and just put those on there directly. Next we've got, okay, these are just from where Go was complaining about overflows. S can also just be the contents of the call. So these are the segments. And that looks like it's about it. So that's all of the test comments that I want to do. So let's go over to the encoder test. I should be able to just get rid of all of these. We'll keep the strings, so the test table will just be a bunch of strings, which will be the listings to test, which means that this is now listing. So tg.listing is now listing, and then tg.cases I'll have to replace with a slice that I just build up. So for example, in here we'll just build up a case and append it to the cases. And so here we'll have some cases, and we'll also need the test string from the end of the assembly. And if we're getting the test string, that means that if we've got the assembly, we can cut on the first semicolon. So assembly test equals strings.cut. So we'll cut assembly on the first semicolon, and then let's just get rid of any space for both of them. So test should now just be basically like one of these lines, potentially with like a double slash trailing comment on the end. So for this one, I just want to split by the fields and loop over all of the fields to build up this test case. So we'll go for I value, we'll range over strings.fields from the test, and then based on the number, I know, for example, that index 0 is always the mnemonic, this one's always the width, so we should be able to just switch on I to say case 0 is case mnemonic equals, and then I need to look up the mnemonic index based on a string. So we'll have a mnemonics map where I can use the value to look up the mnemonic index. The same would go for index for I1, which would be the width. So this will be widths. And this one here is width. Then from this point on, I just need to fill out all of the operands. So we've got op 1, 2, 3, and 4. So in this case, I'll basically be on this part of the string here, and I can split each of these by the dot, where the first thing is always the operand. So we'll basically say, let's do, for example, we've got like the name of the operand and then the attributes. So this would be strings.cut value. Then the attributes, or the operand, would be, I'll have to look up the operand in a map of operands, so it goes from string to the actual operand. Then this would actually be rest of the string, and then attributes would be the split of the rest on dot. So when we're doing operands, we want to look up the name of the operand to get the actual operand. But this is a special case where the first thing is I, to say that we just want to create a new operand. So if name is I, we'll do something different. But otherwise, we'll basically just loop over all the attributes to make modifications to the operand. But this is going to be like, so for example, if we've got .d, this is then followed by like an integer that I'll have to pass, so I need to skip that index. So I can't just range over attributes. I'll have to do, for example, for I equals 0, while I is less than the length of attributes, I++, and then within here, if I need to, I can just skip an index by doing I++. So let's just get the attribute itself, which we'll do a switch on. So in here, I need to switch on whatever these attributes are going to be, which is basically the helper functions for operand here. So I think if we go all the way down to W should be enough. But there are a few here that I'll need to expand out. So SI, for example, will now actually just be X1 to 4, and 8. K will go from, let's see, K will go from 1 to 7 as an attribute, because K0 is not a valid op mask. Z is fine. ER will be the embedded rounding. So that will be RN, RD, RU, or RZ. And then W here will just be the widths. So we've got byte, word, D word, and Q word. Those are valid attributes that I've got for W. So each of these can become a string. These ones here need to sort of join together. Same goes for these ones. All of these K ones can join together into the same case. Basically, I'll group these by the function that they'll call on the operand. So we'll join these together. I think that is all okay, so we'll just put a case on these. And then they're going to do some modification to the operand. So most of them are just going to call the function that's the string. But this one obviously will be SI. So in here we'll basically want to look up scales by the attribute. And then we'll have a name of another operand, which will be attributes I plus 1. So here we'll look up the operand, which will be the index operand. And because we're doing a +1 here, we'll do I++ here to skip the next index. I'll need to do this for the displacements as well. So S here is going to look up, S actually needs to change. This should be the segment register names. So this is actually going to look up segments by the attribute name. Then we've got displacements, which I'll do in a minute. This one is going to be K, where we look up operand based on the attribute. Z is fine, SAE is fine, RN is going to be ER, and this is going to look up a rounding. B is fine, and then this one, W, is going to look up a width. Okay, so for displacements, these are always 32-bit signed integers. So we'll do something like saying N is the next attribute, and we'll assume that it's base 10, but if strings.contains n 0x, then we'll assume that it's base 16. And in this case, we'll also need to replace all 0x with nothing, so remove that. Then we need the actual value, so we'll do a string conversion of parse int, where we'll pass in n base, and this is always 32-bit. So if error does not equal nil, then we'll just do a panic. Or we'll do a t.fatal. Let's just take v, we'll convert this to int32, and then we'll just copy all of this stuff into the other displacement ones. This one's going to change to 8, because this is d8. This one can stay as 32, but I need to call d32 explicitly. So then the other thing is immediates here, which is always going to be the 0th attribute in this case. And this can actually be a signed integer or unsigned as 64 bits. So I'll try parsing as signed first. And then if that doesn't work, or if that does work, we'll just say that operand equals I with v passed in. Otherwise, we will try again with parse uint. If there was an error, we'll do t.fatal, error. Otherwise, operand equals I, where we pass this in, converting it to an int 64. Okay, so I just need these maps now. So I need mnemonics. We need segments, scales, operands. What else do we need? Rounding and widths. I think that should be all of them. So we'll just put this below here. I don't need these overflow variables anymore. Let's just rearrange these a little bit. So we'll do it like this. Scales, segments, yeah, those can go there. Rounding, operands I'll put last. Okay, so for example, mnemonics will be make map of string to mnemonic. And what we'll do is we'll loop over like a static array of mnemonic names where it goes from index to string, and then we can just build the map the other way around. So we'll have the mnemonic index going to a string. And then we'll use this to build up the map here. So this is mnemonic is mnemonic I. And then basically we'll do a similar thing for all of these. So we'll say widths is, well actually widths I can just do as, I could do it as a hard-coded thing. Maybe I'll have, maybe I'll do the same thing for widths as well. We'll make a map of width based on width names. Segments I'll just do as a hard-coded thing here, so we'll do string to flags. So this is where we get CS all the way down to GS. So this will be this string goes to these flags. Scales is a map of string to scale. This is just x1 goes to x1, 2 goes to 2, 4 goes to 4, and 8 goes to 8. Rounding, similar thing, we'll just have this where it goes to embedded rounding. Let's just take these rounding values. And then operands is going to be a map of string to operand. Let's just go find AX. So if I just take all of these, and we'll put them in here. Then I can just get rid of these operand assignments. Make this a string and make it go to the operand that's already been defined. So I just need to build up, let's do the width first. So width is here. We've got all of these consts here. So we'll just say var width names equals a fixed array of string. And then we'll just put all of these widths in. So these go to just their names, like this. And then we'll do a similar thing for mnemonic. Mnemonic is actually getting kind of big here, so let's just put it in another file. We'll just call this mnemonic.go, package x86. Paste this one in. Okay, so we'll do var mnemonic names equals fixed array of strings. We can't do these aliases because these will produce duplicate array indices, but I do need them in the test data. So after we've built this, we'll just manually assign these aliases. So this would be, for example, saying that these strings equal these indices. Okay, so let's just make all of these map correctly. Unknown, I'll just make question marks just so it stands out. Okay, let's just reassemble the listing file, and let's run a test. Not enough arguments. Okay, let's just go and fill that out properly. So this is doing a cut on dot. And then in replace all, I should be using n as the first argument here. Okay, so could not match an instruction form for this. So why is it not matching this? Oh, it's because I need to finish building up the case. So the case, after I've actually built up these operands here, I need to actually assign them, so we'll just switch on I again. So in this case, if it's 2, then that's actually case.op1 equals operand. Then we'll just have case 3, 4, and 5. This one goes to op4, this one goes to op3, this goes to op2. So let's just check if that all works properly. No, not yet. So case 2, 3, let me just check that I'm doing this correctly. Let's just go and print the cases and just see if they've got everything. These all have zeros on them. So case, op1, op2, strings fields test. What is test here? Test is apparently nothing. So we've got cut NASM. Oh, it's because I'm shadowing it here. Okay, that works. So let's just get rid of any prints that I put in, which is fine. Okay, so let's just try and break a test quickly. So let's say we've got CX here. Let's do CX with memory. We'll regenerate the listing, do a test again, and now it fails because it's trying to do a memory access instead. So let's just remove that, reassemble and retest again. Okay, that looks like it's all working fine.